Hey, in this Collab notebook, I am going to explain how to train Stable Diffusion with Dreamboot. There are many resources online available, but I have identified Hugging Face is the simplest one, and you can find their repository on the following link. In this notebook, I am going to explain how to set up Stable Diffusion on Collab, how to fine-tune Stable Diffusion with Dreamboot, and how to fine tune it with also Dreamboot with prior preservation loss, and at the end we will discuss the results. For setup Stable Diffusion on Colab, you have to first register and get the token from the website and then accept the license for the model. You can easily go on to this link and check how you can register on the website of the Hugging Face and get the token. Once you get the token, you have to copy that token inside the Collab notebook. Okay, so I run this code and you can see it's asking for the token. Since I have already token with me, so I will use this token and press the enter button, and I will select the yes, as I want to save this file inside my root folder. So here login is successful and our token is saved inside root folder, and on this link you can go and accept the license. Since I have already accepted the license, so I am just skipping this process. Next step is to download the full Hugging Face repo. Just hit the run button and this folder is downloaded in our Collab storage. Once you download the folder, GitHub repository into your storage, it's time to install the dependencies, and for that we will be redirected to diffuser example and Dreamboot folder, and here we have this requirement.txt file. Before installing this requirement.txt file, we need to install diffuser and this bits and byte package of Python. This installation might take some time. Yes, we have successfully installed every package that is necessary for training Stable Diffusion. Then we have to configure accelerate package. This accelerate package is nothing, just to tell the system either you want to train on local machine or on AWS, either you want to use multiple GPUs or single GPU, you want to use deep speed package or not. So right now I'm just using basic package. Yeah, our basic package is saved inside the YAML file. Now since we have done configuration and installed every required package, now it's time to do training with Stable Diffusion. For that, first we will use dataset. I have taken the pictures of my kid robot toy, and these pictures contains various different background and have different sides. So we will upload them first in Collab. To upload them, so first we will create a folder, and I will name this folder as robot, and from the local directory, not this one, I will upload the files into this folder. Select all, open, and okay. And yeah, so we have 7 different images we can see here. Let's zoom out. So these are the images I have uploaded inside our robot directory. Then we start training with our Stable Diffusion. So we can see here inside our diffuser folder we have example and Dreamboot and this train_dreamboot.py file. This train file we are going to launch with accelerate package, and it requires some additional parameters. So parameters are we pre-trained model path, instance directory path, output path where we want to save our trained model, prompt, resolution of the image, it could be 512 or 256, training batch size, learning rate, maximum train steps, and this is 8-bit add-in optimizer. So this is the instance prompt, so rather I will use v repertoire. So this is our instance prompt, and learning rate is 2 exponent power minus 6. For training tutorial purpose I am using 20, but it's recommended to use 400 steps or 600 steps. It's up to you. You can change and play with these training steps. I will make it to 20. Now I will start the training. So once the training is started, first it will download the model from Convis website, and then it will read the data from the robot folder. This Stable Diffusion v4 is a bigger model, about 3 to 4 GB of size, so it will take some time. Okay, when the model is downloaded inside this cache of our Colab, then it will start training. For training, as you can see, the loss is varying very high. So for some steps it has value 0.0, for other it has 0.3. So I believe if we take more steps, then it will more consistent. Once the training is done, so it will start downloading the model inside our predefined path. This model is bigger, so it might take more time. It's downloading. 72% is completed. Yeah, 100% downloaded. It's still running. We can check what's inside the model directory, and here we can see we have text encoder, we have tokenizer, we have UNet, we have VAE. Different types of networks are there inside this folder. Yeah, so finally we have trained Stable Diffusion using reboot within few steps. So this one is a simple approach we can play with for fine-tuning any of the object. We will take pictures, we can create a folder inside our Colab, upload the data on that folder and execute this folder. Now we will see some different techniques that are recommended for better results, and that technique is training Stable Diffusion with prior preservation loss. So class and instance. Class represent a generic category and instance represent the subcategory. So animal is a class and its subcategory, that is instance, is cat. Prior preservation loss is used to avoid overfitting and language drift. So we generate images from the pre-trained model with the class prompt. It is recommended to generate 200 to 300 images with a single class. And for here demo purpose, we will be generating only 5 images and saving them into the folder. So first I will create a folder and I will name it as new folder, class data. So inside this class data, I will be saving generated images from the pre-trained model. So let's see, I will be using this model and I will be using a generic class prompt R2i. So I will execute this cell and invoke the required packages. Then again I will download the model inside our variable. It will take around 3 to 5 minutes. I will pause video here. Finally our model is downloaded. Then I will send this model to the CUDA. We are sending this model to CUDA so that we can use GPU capabilities. So I am using this prompt, a robot toy, and here I am going to create 5 images from the model, and we'll be saving these images inside the class data. This first image is created, and we can check here, yeah, how it looks like. We have one robot here. Then the third one is also generated and saved inside the folder. This one, the other one, the fourth one, and it's going to generate the fifth one also. We can verify either the images are created or not. Yeah, all 5 images are inside the class data folder, and here I will invoke this command to free up the GPU RAM. Now since data is created, all things are set up, we will invoke training for prior preservation loss. Everything would be similar except we will use here class prompt, instance prompt, and we will be using this width parameter, preservation parameter, and also defining the loss weight here. And one more thing, we define the number of classes images. So since we have created 5 images, these are 5. So if these they will create 100 images, so this would be 100. For demo purpose, I am using maximum step only 20. You can change and play with the max train step. Then we will run this command. It's running. There is some warnings. You can skip it as is. Yeah, here training is started, and loss is varying too much, like 0.063, so this variation is very high. We have completed 14 steps, and we can check also the GPU and memory usages by clicking on this RAM and this button. So our RAM is going fully utilized, GPU is going to be full. Since it's done, now it's going to download the pre-trained model inside this folder. Yes, the downloading and training is completed. So we have seen how it easy to train stable diffusion with various approaches. In this tutorial, we have optimized the models. We just used 20 steps. However, you can do the fine-tuning by changing the resolution, this number of steps, learning rate. You might get better results. Now if we will see how we can generate the results with the trained models. And since we haven't fully optimized the model, the results won't be as good as expected. First we will upload the fine-tuned model inside the Stable Diffusion pipeline. It's taking quite more time. And now we will send our model to CUDA. So we will create a prompt. So here you can see this V. This V is the prompt for the instance, and this robot Y is the prompt for the class. So we try to embed our instance prompt with the class prompt and fine tune the images on it. Now we will run the code to see how the images are produced with our training model. I don't think so that the produced images will be good or will be relevant, or they will look like to our initial data set. Okay, so robot is inside the jungle, but this robot doesn't look like our actual robot, and it's going to produce the second image. Let's see how the results would be. Oh, uh, it has created some poster, I believe. Anyhow, this is the tutorial for training stable diffusion with Dreambooth. You can play with the parameters, and anytime you can get back to me. I will be happy to help you out.